let's look at the think about it. There were a variety of different ways that you could prove that our figures shown were congruent. One of the ways is that I could use the ruler part of my protractor to measure the lengths of all four of my sides and use the angle part of the protractor to figure out that the angle measures were all the same, so these shapes were in fact congruent. We could also use the distance formula to help us here, but more generally, anytime we are performing a translation, rotation, or reflection, any of those rigid motions, our pre-image and our image are going to be congruent to one another. So because all I have done in moving from A to B, B to C, and C to D is change the position and in some cases the orientation of the shape, they have not gotten any larger or smaller, therefore they are congruent. This leads us to our big idea for today, which is that two figures are congruent if there is a series of rigid motions, so that's translations, rotations, and reflections, that can map the pre-image onto the image. Go ahead and capture this in your notes. Now let's move on to the INM. So the question, step A in the INM, asks you to determine the coordinates of a triangle after two different transformations. So when we do this, just like we did in the think about it, we're going to treat each transformation individually. So we're going to perform one transformation, get an image, and then perform our second transformation to get our final image. So the same way that we practiced this week, you're going to set up a table of values and fill in our transformation rules. There's an anchor chart at the front of the room if you're not sure what this should look like. Go ahead and plot your pre-image and then find the coordinates after the reflection y equals x. So as you can see here, I started off by listing the coordinates of my pre-image and then reflecting over the line y equals x using that rule yx where we switch the coordinates. I've used my prime notation here since this is the first image. I can also see this on my graph. So here is the graph of my triangle and my first image after the reflection across y equals x. Notice that I used that prime notation. I also drew in my line of reflection. I can do a quick mental check to see that my pre-image and image still look congruent, so I'm on track to do this correctly. My next transformation is to translate this first image along the vector -4, 2. Go ahead and fill that into your table and then also graph your second image. So as you can see here, I continued the next column of my table to create w double prime, x double prime, and y double prime, which I got by just translating my w prime, x prime, y prime by this vector. You will notice that I've highlighted this in yellow and this in pink. That's because on my graph, I have actually drawn these corresponding images in a different color just to help me keep my work straight. So there's that first reflection, and then I translated this shape over for up to, which you can see that vector visually here as well. My pre-image and my image are still congruent to one another, so I know I have done this question correctly. So step B asks you to figure out whether the image of triangle WXY will be the same if the composition of transformations is done in the opposite order. So meaning rather than reflecting and after a translation like we did in part 1, we are now going to translate and then reflect. Create a table of coordinates like we've practiced in your notebook and use your coordinate rules to determine whether the coordinates of the image would be the same if we did them in reverse. You can also prove this graphically. You don't have this coordinate grid, so just do that in your notes if you would like to. Teachers, please put 3 minutes on the clock for students to do this, and pause the video. I will post the answer after this. So here is the table of values for when I did the composition of transformations in the opposite direction, when I translated first and then reflected. Notice that my coordinates in my reflection, when it's second, are not the same as when it was first, right? Here are the two sets of coordinates together. You can see very clearly that we get totally different image points when we do these compositions of transformations in a different order. So this leads us to a really important concept for today. Please capture this in your notes. The order of transformations matters in a composition of transformations. You're now going to move into independent practice. You have a handful of student helpers who are available to support you, but during this time you are working silent solo, so completely independently. You will have an exit ticket at the end of the period, so it is crucial that you are maximizing your practice time. Please use the graphs in your packet as well as a table of coordinate values in your notebook, just like we have practiced, to help you answer these questions. Good luck today. I can't wait to see the wonderful work you put down on paper. Have a great day.